Okay, so the 23rd problem in the lead code is to merge the case sorted list. So if you remember, we already solved a similar question like this. Like basically in the previous problem, what was it was like we will be given the two linked list and which are already in a which are already sorted. So outcome is we'll have to merge it, and outcome should also be in a sorted order, right? That we have already solved. But here, what is the change is we'll have to merge the case sorted list. Okay, so it can be three linked list or four, five, whatever it is, right? It depends on the key value. Okay, so now here we are given the list here, list of linked list. Okay, and then we'll have to merge it. Now there are multiple ways of approaching this. Initially what I did was so already we know how to merge the two linked list, right? So I rewrote the code here. Okay, merging the two linked list. So yeah, this I already explained in the previous video also. So this is the way like how to merge the two linked list, correct? And now what I have done here is I've set my initial result node to the none. Okay, initial result node to the none. What I'm basically doing is I'm sending the two list at a time and asking to compare it and merge it. Okay, so let's say that initially I will send these two list and get the result, and whatever the result I get I will compare it with this. Okay, initially as we don't initially I have set the result to the none, and I will compare the none with this. Obviously we'll get this as a result. Okay, and then from then I will be comparing the result with the whatever the element that is coming in, right? The result is equal to none. This is what I was initially doing. It was the accepted solution, and like I mean compared to other Python codes which are already submitted, it's like 17% only efficient. Okay, so now, right, what are the other approaches that we can solve this? Okay, so now coming to the actual implementation. So let's say that we already know how many times we know that this is in a sorted, and outcome should also be in a sorted order. Okay, so now what we can do is, let's say that if we know the occurrences of each values, right? Let's say that one has occurred for twice and four has occurred twice, two is once, three is once, five is once, six is once, right? So I can build a new linked list, right? I will add it to if I know the occurrence, I can build a new linked list saying that okay, one has appeared twice. I will add the two ones in the beginning, and two has appeared only once, three, and four has appeared twice in the provided list. So I will add two fours and five six, right? So this is what is the logic now. So what we'll do is we'll iterate through this, and we'll store it in a dictionary. Okay, one has occurred how many times, three has four has occurred how many times, right? We'll store it in a dictionary, and then at the finally what we'll do is we'll iterate through the dictionary and build a linked list, final linked list. Okay, so to make our task easier, right, let's say that I'm building some if I want to store these values, right, let's say that occurrences it's best to go with a default dictionary, because let's say that I want to iterate through it and maintain the count, right? So let's say that when I go to two, if I use the normal dictionary, right, what I will have to do is I will have to check the two, like I mean if it exists or not. If it not exist, I will have to enter it and append it, and also with the value one or zero, right? And that's like a too much thing. So we can go with the default tick. It will take care of for doing all those things for us. So we'll what we are doing now here is we are iterating. We'll pick the first list, we'll set our dummy node. Okay, we'll set our dummy node and we'll start iterating through the node. Actually basically we are here and we will be iterating through this in the first iteration. Okay, we'll be wherever let's say that we encountered one. Okay, this is for the first time, and this is for the first time we'll be incrementing the value, right? This is for the we'll be incrementing our value. Okay, and let's say occurrence, this is only occurring for the ones, we'll be incrementing it, correct? And similarly we have repeated 1 4 5 1 3 4. We'll do this and we'll build our dictionary here. Okay, we'll build this dictionary. Okay, once that is done, right, we know how often this is occurring, right? And now what we'll do is we'll just sort that default dictionary. Okay, we'll sort it based on the keys, and then we'll pop one by one, right? We'll pop one value, and then we'll build our new linked list. We have created dummy node here, and then we'll be creating iterating through that whatever the value that is popped, right? How many times it is popped, right? Like how many times it is there in the dictionary. Based on that we will be building the new linked list. Okay, this is one way. Okay, and this is second way. Basically, like here we discussed about how to reuse our old code, right? How to merge the two list, and here it's about using the default dictionary. Like we'll be storing our occurrences and build a new linked list. Thirdly, what we can do is we can use a heap data structure here. If you are aware, in the heap data structure there are two types, right? Minimum heap and maximum heap, right? So how does it look? So this is how it looks. It's a tree data structure, right? If it is a minimum heap, it is nothing but parent node is always less than or equal to the child node. Right, it is a parent node. It is always equal to this. It can also be 3, it is less than or equal to. Okay, this is the minimum heap. In the maximum heap, what it will be is the parent node will be greater than the child nodes. parent node is 15 and it is 10 12. Okay, this is the minimum heap and max heap. And what is the primary use case is we can use this to build the priority queues. Okay, so what does a priority queue mean is, let's say that we can set a priority. Let's say that I will build some queues and I will associate some priority to it. Okay, and based on the priority I can pop it. Okay, let's say that in the minimum heap, so whatever the value, the priority, if it is 0, right, so that will be popped out. Okay, and if it's a max in the maximum heap, whatever the maximum priority one, right, maximum value, that will be popped. Okay, so how we can use that here, correct? So here what we have done is we have used the default dict and stored those values, right, and sorting this, reversing it, and all those things we did, and we got the output. So initially in the case of heap, what we can do is we can put all this data to the heap. Okay, so, and also we can, let's say that first initially I will iterate through all this and I will put everything to that data structure, heap data structure, minimum heap. We'll use a minimum heap here. Okay, like meaning that whenever we pop it out of the heap, we will get a minimum value. Okay, so we will put all this value into the minimum heap, and then now we'll pop one by one value. Okay, so let's say that I think I have it somewhere here. Okay, let's say that I will push it here, and then what we can do is we can pop one by one. Once we pop it, we'll always get a minimum value, right? Whatever the value, whatever the way order you push that, push your values to the heap data structure, right? In the case of minimum heap, we will get a minimum value as it's a priority based one, right? Priority queue, it's nothing but. Okay, so when we pop, we got a minimum value. I don't have to worry about sorting those things. I got a minimum value. I will just build a new linked list using that popped value. Okay, this is one thing. Okay, and now what we just did is we are iterating through all these nodes and putting this into the heap data structure. It might constitute the memory complexity, correct? Like we are putting all these values into one heap, and it will increase the increase the memory complexity, right? So instead what we can do is we can just add these values, whatever the node values, head values, right? We'll store these values, we'll store this node, and we'll store this value inside a heap. Okay, and before inserting one, there is no chance I will be inserting 3 and 4, right? As this is already sorted, before I insert one, I don't be inserting 3 and 4. Before I inserting two, I won't be inserting 6. So that is the idea here. So what we'll do is we'll be inserting only the 1 1 2 initially, and also we'll be storing the node also, so that we can refer to this later, right? So now what we can do is we'll add this to the heap, and now we'll try to pop it. Okay, we'll try to pop it, whichever is minimum will come into book, will come, and we'll add it to the list. And now we'll insert the new element to the heap. Okay, now we have popped one, right? So we'll have a reference. As we push the node also, we'll have a reference to, so we'll push the 4 to the heap now. Okay, so when the next time when we are popping it, right, whenever we are popping, it is still one, right? There is still one left, so we'll be getting this, and then we'll add a 3 later to the heap. This is how it is working. And just to show the code, right, the code looks like this. Okay, we'll be having on priority queue, and we'll be adding heads, whatever the heads, right, for in the linked list, we'll be pushing to the heap. Okay, and then we'll be iterating through it, we'll pop it, we'll create a new list. And once we are done, right, and we'll pick the next one, we'll pick the next one to the, and push it to the heap again. Okay, and maybe in the next iteration also that will be considered. So to summarize, there were multiple ways we discussed here. There are multiple ways we discussed. Um, Wrong window. Okay. So here, yeah. So basically, there are one was two node, right? We're using the merger to list, like I mean merging any two linked list, and the secondly, using the default dict, storing the occurrences and building a new linked list. Thirdly, we can use a heap data structure. Either we can store all these things and pop it one by one. That is also there. That will increase the memory complexity, and to that will reduce the to reduce the memory complexity, we'll just have to add the head node, and then when reading it, we'll have to take the we'll have to add the new elements here. That's it. Thank you.